So, okay, now I have created the virtual environment named Wichita State University Subas. And this Wichita State University, all the modules like TensorFlow, Scalon, NumPy, Pandas, and Matplotlib has already been installed. You can see from here. So now we are ready to execute our program, the Python program. So let's see what Python program that we want to execute. The first script that we need to make is that let's see our Python program. Okay, first the Python program is HPC ANN example.py. Stops here and share again. So I will basically briefly describe about this one. So we will import the modules, and we will load the MNIST dataset by this command. And then since the MNIST datasets or the picture or the images are in the 1 to 20, the intensity of the pixel is in the range of 0 to 255. So in order to do that, we need to scale them into 0 to 1, because machine learning or deep learning classifier takes in the normalized form 0 to 1. That's why we divided by 255. Then after we save the train and test, and then after what we do is that I create a model. Since this is a 28 by 28 matrix, the matrix this is a two-dimensional matrix. We need to change this two-dimensional single channel two-dimensional matrix into a one row feature vector. So that is done by the dense, and then after we input the 128 neurons dense layer, then after drop out at the last we have the 10 neurons, because there are 10 classes, and the softmax activation functions, because we'll get the probability of those 2 and 10 classes, so we need to do it by softmax activation function. Similarly, we need to compile the model, and the model.summary shows what kind of model that we are using. We'll use the optimizers sparse. Since it is a 10 classes, so we are going to use sparse categorical cross entropy. Let me do only 10 epochs. Okay, 10 epochs, because if I do 100 epochs, it will take some time. So let me do some 10 epochs. Okay, again, let's see, it's been saved. Share again. Share. The video has been recorded. After that, so we are going to feed the model. We are fitting the model. These are the training sets, and this is the validation sets. Here the training sets and test sets are being divided into train and test set. There is 60,000 number of training and around 10,000 number of testing. So after that, we use a epoch number of 10, and we fit it in this. In the first one, we get the loss curve graph. On the second one, we get the accuracy curve graph. We'll see it, and then after we'll create the confusion matrix. I think I shouldn't explain about these all the things, because if you are a machine learning and deep learning expert and person working in the field, so I think you will know about all these things pretty easily. So okay, this is the HPC ANN example.py, and at the final we'll see the plot the confusion matrix, and we will see what is the prediction accuracy of these this model that I have just created. It is a basic deep learning model and basic deep neural nets model with one hidden layer, one input layer, with one input layer and one output layer. I think there is no hidden layer. There is just one input layer, dense layer, and next one is the output layer. So these are the things. Now let me execute this one. In order to execute this one, what we need to do is that before that I just need to show you this aspect command. Okay. Okay. Share the screen. I'll share it. Okay. Now, in order to do that, now we will basically need these directives. This command bin bash, and we'll have the memory of this is 30 GB RAM. 30 GB RAM. If you need 200 GB, 400 GB, also you can talk to the HPC admin or HPC help. They will configure how much amount of RAM, random access memory you need. And then this is the number of cores that we have, 60 number of cores, and this is the number of times that we learn for this program, that's 24 hours. And this is the number of GPU, 1 GPUs. in BOC HPC cluster, there are four NVIDIA Titan version 100 16 GB GPU. So among those four, you are getting one. And in order to use this GPU, we need to load this module. Okay, I have already said you that force CUDA should be here, not only CUDA, force CUDA. If there is no force CUDA, then the GPU will not be loaded. Then after, we need to activate the module. We need to activate the what we need to activate. We need to activate the virtual environment. Over here I have written BOA. Just let me change it. Okay, what is the name of the virtual environment? Okay, the name of the virtual environment named is WICHITA Wichita underscore STAT underscore university underscore SUBASH Wichita WICHITA underscore STAT underscore UNIBRSITY underscore Subhas. Okay, so this is the virtual environment. After that, yes to all. After that, we will use this one. Okay, HPC ANN example. This one was the program that I showed you recently. Before this file, that one was the file we will execute. Now let me execute this program. So how do I execute? Stop share and share again. Now let me share. Now what we need to do is that CLER. Just a moment. Okay, stop share and then share again. Okay, now what we need to do is that we need to execute the command, right? We need to execute .sh file, this file. Okay, this file is the file that will execute this program. So we need to execute this one. So in order to execute that one, what we need to do, sbatch tilde / HPC underscore ANN underscore example.sh. Okay, now we need to track this this file. Okay, 383957. So all output will be in this file. Okay, so in order to track that file, what we need to do, that cat is cat, or we can use the list, but cat is the command that only shows the brief information that we need. If we do list, then it will show me a huge amount of information that's not required at all. SLURM slom dash 383957 out. So all the outputs are in this file. Okay, cat slom 3839 output. Although the file, job name is 383957, but the file is created. File name is slom 383957. Let me see this one. Okay. Okay, no. Slum 38. What happened to that thing? Let me see. What happened to this thing? Stat -j 383957.out. I think it's failed, right? It's pending. Okay, it's pending means other people are using the HPC, so it's in the pending. Why is it in pending? Okay, maybe stat. Okay, so what happened over here is that the process is in pending. This means that it will take some time for me to get these resources, but anyhow, this is the process how you will be able to execute the HPC cluster. At the end of the day, what we need to do is that you just need to see this output. Okay, but as is in pending process, it's in the pipeline. It will get executed after some time or some moment. So this is the way how you can run the Python file through the sbash command. Thank you.